Hi, welcome to this second introductory video where we'll be seeing the all-important contributions to geometry of a certain Mr. Euclid of Alexandria. In the previous video we had seen that geometry is the knowledge of shapes and their characteristics. However, in ancient times, the understanding of the characteristics of shapes was not the same everywhere. This was because there were four fundamental problems which Mr. Euclid recognized and solved. The first problem was that geometric knowledge was scattered unevenly, meaning people in some places knew more, whereas people in other places knew less, or even very little. Mr. Euclid solved this by collecting all the geometric knowledge up to his time. Now, this was not easy. This, in blue, was the kingdom of Alexander the Great, succeeded to by Ptolemy, in which Euclid lived here in the city of Alexandria. So, one can say that Euclid must have contacted mathematicians at least across the length and breadth of his vast home country. You can imagine how costly, difficult, and time consuming this must have been. Anyway, after this, Euclid went on to solve the second problem, which was that the knowledge of geometry was not organized. Obviously, since it was never collected in one place till then to be organized. So, Euclid put all this collected knowledge in order, from geometry of simple shapes to compound shapes, and also for each shape from simple characteristics to advanced characteristics. Then Euclid addressed the third fundamental problem, which was that while some characteristics of all shapes were obviously true and therefore not disputed, most characteristics of all shapes were not proven, meaning not demonstrated, that is, not shown logically to be true. Attempts to prove these by drawing the shapes and measuring led to disputes as alongside, because accurate drawing and measuring instruments were not developed then. So Euclid proved the characteristics of shapes one by one in a completely different and indisputable way by using only logical reasoning as below. Firstly, he took the obviously true, undisputed characteristics of all shapes to be absolute truths. For example, an undisputed characteristic of straight lines was that if there be a straight line and a point on it, then the angle formed around the point on the straight line is equal to 180 degrees. Obvious truths are called axioms. Next, using axioms, he proved the simple characteristics of shapes, which could be proved by using only axioms. To extend our example in today's way, an unproven simple characteristic of straight lines was that if there be a straight line and a point on it, and if there be another straight line on it from that point, then what will be the sum of the two angles formed, angle 1 and angle 2, be? Now you will say, how simple, since the whole angle formed as per the axiom is equal to 180 degrees, then the sum of the parts, angle 1 and angle 2, will also be equal to 180 degrees. So, we have used only an axiom and demonstrated characteristic 1 of straight lines, that if two straight lines are like this, then the sum of the angles formed is equal to 180 degrees. Proven characteristics are today called theorems. So this is theorem 1. Thereafter, using axioms and the proven theorems, Euclid proved the advanced characteristics of all shapes. To see an example of this, when two straight lines intersect, four angles are formed. The disputed characteristic was, are the vertically opposite angles equal? That is angle 1 equal to angle 3 and angle 2 equal to angle 4? And this Euclid demonstrated to be true as follows. If we consider this straight line and this part of the other line, then we have a theorem 1 situation, That is, angle 1 plus angle 2 is equal to 180 degrees. Let's note this at the side. Similarly, if we take this other straight line and this part of the first line, then again we have a theorem 1 situation. That is, angle 2 plus angle 3 is equal to 180 degrees. Let's note this also at the side. Now please see the notings. If angle 1 plus angle 2 is equal to 180 degrees and angle 2 plus angle 3 is also equal to 180 degrees, then angle 1 plus angle 2 is equal to angle 2 plus angle 3. And if from both sides we remove the common angle 2, we are left with angle 1 is equal to angle 3. That is, the vertically opposite angles are equal. And we have just proved the second characteristic of straight lines by using the 180 degree axiom and theorem 1. This proven characteristic is called theorem 2. We can similarly demonstrate that angle 2 is equal to angle 4, which we will do in a later video. Now, to note this demonstration process in simple terms, firstly, state obvious truths. Next, use obvious truths to prove simple things. And then, use obvious truths plus proven simple things to prove advanced things. You can pause the video now and double check. And in this way, Euclid proved all the characteristics of all the shapes, and thus Euclid had with himself the whole proven geometry. But he had not yet presented his whole proven geometry to the world. So Euclid published his collected, organized and proven knowledge in a book named Elements. Now, in those days there were no printing presses. Publishing meant hand copying by paid professionals called scribes. Euclid's book was so much demanded that even after Euclid, it continued to be hand copied and sold for about 1700 years until the printing press was invented in the 1440s, when it got printed in modern form. The book was in 13 volumes. The first 6 volumes were of geometry and the remaining 7 volumes were of other mathematics. And when printing presses became common, it is said that Euclid's Elements was the second most printed book in the world after the Holy Bible. Also, the book was so much in demand because not only was the knowledge of shapes and their characteristics required in all work concerning shapes as seen in the previous video, but also Euclid's technique of demonstrating was found to be useful in all work not concerning shapes. To take one example, in a court of law, to win a case, a lawyer has to demonstrate his point logically and not shout about like here, where the judge is annoyed and the accused is happily giving a thumbs up because he is getting away. One notable person who had realized this was Abraham Lincoln, easily the most famous president of the USA because he abolished slavery. It is said that when he was in law college, he had taken a break, studied Euclid's first 6 volumes on geometry to learn how to demonstrate, and then only returned to his law college and gone on to become a successful lawyer. To see a few more examples, you have to demonstrate to convince the customer about your product in marketing and sales, your investment scheme in banking and insurance, your business plan in management, and so on in all commercial and financial activity. And this is why geometry is part of the syllabus for the entrance tests of even non-mathematical and non-science careers. Okay, now to summarize and remember what we learnt in this video. The purpose of this video was to see the contributions of Euclid to geometry. And what we saw is that Euclid had solved all the 4 problems of geometry. Firstly, he had collected all the far-flung knowledge of geometry. Secondly, he had organized all the collected geometry from simple shapes and characteristics to difficult. Thirdly, he had proved the characteristics of all shapes with irrefutable logic. Finally, he had published the proven geometry as a whole to the world, making geometry available to all, which in turn made the understanding of geometry the same everywhere. The publication of Euclid's book also brought out that Euclid's method of proving was a requirement even in non-mathematical and non-science matters. So, Euclid had transformed geometry into a collected, organized, proven and published body of knowledge. Hence, because of Euclid, the very definition of geometry got upgraded from geometry is the knowledge of shapes and their characteristics to geometry is the body of knowledge of shapes and their characteristics. And for doing this, the world honors Euclid with the title the father of geometry. Alright, in this video we saw the contributions of Euclid to geometry. In the next video we will be seeing that from the time of Euclid to date, there have evolved 3 distinct types of geometry. I'll see you there.